Welcome to Ask and Learn.
So in this question, we have a capacitor, 2.2 microfarad capacitor that is initially connected to a battery and fully charged. And then it is disconnected, and then it is connected to another capacitor that is 3.5 microfarad. So we want to first determine the total energy when the two capacitors are connected, and then after they're connected, and then what's the change of energy. So before they are connected, so 3.5 microfarad one, it has no charge, so there is no energy that. So we only need to find the energy on this 2.2 microfarad capacitor. And the energy is 1/2 of Cv squared. We know it's 2.2 microfarad, and we know is 12 volt. Okay, and this gives us 1.58 times 10 to the negative 4 joule. And in part B, what we have is that now these two capacitors, they are connected. I guess the question is, are they connected in series or in parallel? I think in these cases, usually we think of them as they're in parallel because both of them have the same voltage on the left side and the same voltage on the right side. So the equivalent capacitance will be the sum of both of them. And then let's look at the charge. The charge of them, the total charge, is equal to the individual charge. So this is, if C1, because it's C1, C2, this is equal to the charge before they are connected. So with these, we can find the new energy, that is what we can use Q squared over C. And Q is the same Q, but C is equivalent capacitance. So in other words, that is C1 squared, E0 squared, over C1 plus C2. So this is C1 is 2.2 times 10 to the negative 6 farad times 12 volt squared over 2 times 5.7 times 10 to the negative 6 farad. And this is 6.11 times 10 to the negative 5 joule. And last step, we need to find the difference. Let's call this U1, this U2. The change of energy is the difference between these. And this is negative 9.3 times 10 to the negative 5 joule.